So basically, this link relative method uh, is developed by Carl Pearson, and hence this method is also known as Pearson method of seasonal variation. So this method involves some steps like conversion the original data into link relatives. I'll share with you this formulas. Link relatives of seasonal variations. We have some problems in this, so we learn that problems, and we'll complete this unit. Yeah, here we go. Yeah. So this is the formula for link relative of seasonal variation, and we'll see some problems in that. And last topic is the seasonalization of vari- variations. See the formula so that we'll start with problems. I'm sending you the problem. Adjust the following time series data for seasonal variations. We are given here the years and first quarter, second quarter, and third quarter and its values. So this is the problem. Yeah. So continuation of that problem we are seeing here, how to do this. So this is the question given to you, and question is calculate, adjust the following time series data for seasonal variations. So they have given us here first quarter, second quarter, third quarter, and fourth quarter. So what we need to do, what we need to do, see, as previous problems, we need to make the total of all the values. Total of first quarter, second quarter, third and fourth quarters. Then make find out averages. How many years are there? 4 years. 12, 13, 14 and 15. Total divided by 4. We get averages. Here we need to find out what is seasonal indices. So how we need to calculate this seasonal indices is important. So here what how we get the average of quarterly averages means whatever the averages we got for all the 4 quarters, that is first quarter 3.675 plus 4.125 plus 3.55 plus 3.55 divided by 4, we have 4 years, so by n, that is 4. So 14.9 by 4, we are getting 3.725. So how we need to calculate this index or indices means first quarter. What is the average? Average divided by average of quarterly average into 100. So 3.675 divided by 3.725 into 100. So first quarter we are getting 98.66. So here we got the first indices, that is 98.66. And second quarter 4.125 divided by 3.725 into 100. We are getting 110.74. As usual for third quarter and fourth quarter, Third quarter 3.55 divided by 3.725 into 100. So we are getting 95.3, and for fourth quarter also 95.3. So it is very simple to understand this link relative seasonal variations. And coming to next problem, same method. So next to 21st problem, calculate the index seasonal index from the following averages. So see, here also they have given us the same thing, quarters, first, second, third quarter. But is what is in here? 1, 2, 3, 4, 5, 6. So we got 6 here. So first, what we need to do as usual. We need to make total, and we need to make the averages. And what we need to find out? We need to find out average of quarterly average. So first make the totals of first quarter, second quarter, third quarter, and fourth quarter, and then find out the averages. 376 divided by 6. So next, finding out of averages, what we need to do, we need to find out seasonal indices. So how you find out seasonal index or indices means, make the totals of averages. Quarter 1 average plus quarter 2 average and plus quarter 3 average plus quarter 4 average divided by 6. Why 6 means we have 6 years. Yeah, see, by 4, sorry, 4 quarters. So same like previous problem also we did the same thing. Uh, average by average of quarterly average into 100. So like that only we get the all seasonal indexes. So now what we need to do, we need to find out. We'll do one more problem and we'll see the deseasonalization, and we'll close the time series topic, and we'll start with index numbers. So these problems are very simple and interesting and even important for your exam purpose. So this is the last question based on link relatives of seasonal variations. So that was the question. Yeah. So if you see here, they are given a question like assuming no trend in the series, calculate seasonal indices for the following data. They have given you the years 2011, 12, 13, 14, 15, and quarters: first quarter, second quarter, third quarter, and fourth quarter. Same we need to do. First, we need to make the totals of all the quarters individually: first quarter total, second quarter total, third quarter total, and fourth quarter total. After doing, we need to divide the total with average. Sorry, we need to divide the total with 4 because we have 4 quarters: first quarter, second quarter, and third quarter, fourth quarter. So, total divided by 4, we'll get the averages. After getting the averages, we need to find out the average of quarterly averages. So, what is quarterly averages? Adding of all first quarter average, second quarter average, third quarter average, and fourth quarter average divided by 4. So, we get the average of quarterly averages. So, then we need to find out seasonal index for first quarter, second quarter, third quarter, and fourth quarter. How you will calculate the seasonal index means first quarter means average divided by average of quarterly averages into 100. So 75.2 by 76.4 into 100. So you we get the first seasonal index of first quarter. Then similarly for second quarter also 70.4 divided by 76.4 into 100. We get 92.1. For third quarter 83.2 by 76.4 into 100. 108.9. Then last quarter 76.8 by 76.4 into 100. 100.5. So this is about link relatives of seasonal variations. Now we'll do deseasonalizing the see the next question. Deseasonalizing the following sales data and interpret the results. So here in the question itself they have given us sales and even seasonal index. So quarter 1, quarter 3, 2, quarter 3, quarter 4. 4 quarters they have given you. We have mentioned quarterly, quarter in horizontal way, sales, seasonal index, and seasonalized sales. So see for first quarter the sales are 23.7 by seasonal index into 100. So how much is your seasonal index for first quarter? 0.78. So 23.7 by 0.78 into 100. We get 3038.46 is our deseasonalized sales. For second quarter, 25.2. What is seasonal index? 1.27. So 25.2 by 1.24 into 100. 2032.26. Similarly, third quarter 21.4 Seasonal index 0.50. 42.80. Similarly, fourth quarter 65.4 by 1.48 into 100. This is about deseasonalizing the sales. So now we'll start with the index numbers. So what is index numbers generally? The statistical device which measures related variables and provides representative figures as regards the combined changes in the variables is called index numbers. So the technique of index numbers was developed by Bishop Fleetwood in 1707, but actually credit for sharpening and application of technique goes to G.R. Carli, an Italian statistician who applied the device of index numbers in studying the behavior of changes in the price level in the year 1750 as compared to the price level of the year 1500. However, the real use of this technique became popular only after 1860 with the work of King, uh, Irving Fisher, Marshall, Gibbons, Hedgeworth, and so on. So, general index numbers are today one of the most widely used statistical devices. They are used to feel the pulse of economy, and they have come to be used as indicators of inflationary or deflationary tendencies. So, what is index numbers? Index numbers are the device for measuring differences in the magnitude of a group of related variables. So, coming to the different types or kinds of index numbers, first we have price index number. In price index numbers, we have two types: wholesale price index numbers, and second one is retail price index numbers. Second one we have quantity index numbers. Third one value index numbers. Fourth one cost of living index numbers, and last one is special purpose index numbers. So coming to the methods of constructing the index numbers, we have two types. First one is unweighted index numbers, and second one is weighted index numbers. So I'll share the importance. uh, Constructing the index numbers. We have to unweighted index numbers are two types: simple aggregative method and simple average of relatives method. And weighted we have so many types like Lapras, Pache, Fishers, like that. So weighted index numbers are of two types: weighted aggregate methods and weighted average of relatives method. So first we'll deal with weighted index numbers. So here we'll have a base year and we got some formulas. Yeah, these are the formulas for simple index numbers and weighted index numbers. So these are the formulas. So we'll start with the problem. Yeah. So see the question here. Prepare an index numbers from the following data. Base year is 2007. So here they have given 2007, 8, 9, 10, 11, 12, 13, 14, and 15, 16. They have given even the price. So here how we need to find out if base year is 2007. So base year 2007 means the year will not be changed. The values will not be changed. It is considered as 100. So see 2007 equals to 100. So the fixed base index will be 100, but price is same 67, whatever the given in the question. And see 2008. Uh, so they asked us 2007 as a base year. So the denominator will be the base year for all the years. If you see second 2008, what is the value? 90 divided by 67 into 100. So we are getting the fixed base index number for 2008 as 134.3. Similarly, for 2009 also see, they have given you 91 price by fixed year's price is how much? 67. So 91 by 67 into 100. We are getting 135.8. Similarly, next year 2010, that is 92 by 67 into 100. We are getting 137.3. Next year 87, 2011, 87 is the price value. So 87 by 67 into 100, that we are getting 129.8. Even for 2012, 88 by 67 into 100, we are getting 131.3. Then 2013, 89 by 67 into 100, 132.8. Then 90 by 67 into 100, that 134.3. Then 97 by 67 into 100, 144.7. Then we have 98 by 67 into 100, 146.2. So see next problem. Yeah, see, second problem. They have given us calculate index numbers for 2010, 12, 13, taking 2010 as the base year with the help of simple average of price relative method by using median and mode. This is a question given to you. So here, if you see the problem, we they ask us to find out price index for 2010, 12, 13, taking as 2010 as base year. Yeah, see. So prices in 2010 A, B, C, D, E they have given us 11 prices in 12 prices in 13. So here they ask us to find out 2010, 11, 10, 12, 13 and price index and 2010 as base year. So 2010 items, what are the items? A, B, C, D, E. C year and prices of 2015, 15, 10, 12, 8, and 17. Then what is price relatives? Price relatives we are taken as 100 because 2010 is as base year. Yeah. So next what we need to do, we need to find out 2011 price relatives. What is the price here? 30 into 100 by 15. What is 15? 15 is base year. A item 2010. So we are getting 200. Similarly, next one, 12 into 10, 12 into 100 by 10, 120. Same next one, 18 into 100 by 12, 150. Then 8 into 100 by 8, which is equals to 100. Then 15 into 100 by 17, 88.23. Then 2012 prices, and we need to find out what is price relative. So 20 into 100 by 15, 133.33. 16 into 100 by 10, 160. 8 into 100 by 12, 66.67. 12 into 100 by 8, 150. 16 into 100 by 17, 94.12. Same 2013 also we need to do like this only. So coming to, they ask us to find out by using median and geometric mean. So for 2011, 2012 and 2013 they ask us to find out. So arranging relative price relatives for 2011. What we have 200, 120, 150, 100 and 88.23. So we need to arrange it in ascending order. Ascending order means small to big. So first we have written 88.23, then 100, then 120, 150, 200. Then what is the formula of median? N plus 1 by 2. What is n here? Number of items 1, 2, 3, 4, 5. So 5 plus 1 by 2th term. So 5 plus 1, 6 by 2. We get third term. What is third term here? 120. So price relative for 2011 is 120. Similarly, we need to do for 2012 also. So arrange it in all ascending order. First we get 66.67, then 94.12, 133.33, 150 and 160. The same formula, n plus 1 by 2, 5 plus 1 by 2. So third item is here how much? 133.33. Similarly, 2013 we need to do. Uh, we need to arrange it same formula, n plus 1 by 2, 5 plus 1 by 2. So third item, here third item is 130. So by using median is over. Now we need to find out by using geometric mean. Geometric mean for 2011, 2012 and 2013. So 2012, 11, we need to put all the price index values according to the items to 200, 120, 150, 100 and 88.23. Then we need to find out what is log P. So log values we need to find out. Log of 200 how much? We are getting 2.3010. So for every item we need to find out what is logs. Log of 120, like that. Log 120 is 2.0792. Then log 50, 2.1761. Then log 100, 1. 2, sorry. Then log 88.823, 1.9456. Now make complete total of log values. So we are getting 10.5019 sigma log p for 2011. Similarly, for 2012 also we need to find out log values and make the summation of log p. So here uh, log 133.33 we are getting 2.1249. Similarly for 160 like that we need to find out the total, and we need to find out for 2013 also. Now what we need to do? We need to find out geometric mean, means anti-log. So finding out anti-log for 2011, 12 and 13. So what is the log p for 2011? 10.5017 by n log 5. So log anti-log for 2011 is 126, and for 12 is 115.1, 2013 is 132.4. So see the next problem. The following are the index numbers of the prices. Base year is 2000. So we have 2001, 2, 3 up to 2015. So index is also given 100, 107 like that. So we need to put in a horizontal way. So we need to find out what is new index number. So 2000 is base, so 100. So 100 by 240. 2010 is base year, I guess. Yeah, 2010 is base year. So see, 100 by 240 into 100. Say 107 by 240 into 100. 108 by 240 into 100. Then 95 by 240 into 100. Similarly, all the values. All the values, if you do like this only, taking 2010 as base here. See 2013, 14 and 15. So this is nothing but your finding out price relatives. Now we'll see some other problems. Uh, yeah, see this problem. Construct index numbers by two methods, simple aggregate method and average of price relatives. So they have given us commodity 1, 2, 3, 4, 5, then prices in 2011 and prices in 2016. So what we need to do, they have given us the commodities and prices. So P1 is current prices, P0 is previous price years. So P1 by P0 into 100. So P1 is 75 by 50 into 100, 150. Similarly, second year also 60 by 60 into 100. Then 12 by 100 into 100, 12. Then P1 18 by 15 into 100. Then 35 by 25 into 100, 140. So we need to make the total of both the sides. I mean both price 1 and P0 and P1. Then sigma P1 by P0 into 100. So we got 522. So we need to apply the formula here. That is finding simple iterative method. Sigma P1 by sigma P0 into 100. 200 by 250 into 100. So we are getting 180. See, uh, we have seen there now average of relative method, that is sigma P1 by P0 into 100 by n. So 522 by n. N is how much there? 5. So 522 by n is 104.4. So this is the problem. Next problem, from the following data construct index number for 2015 taking 2010 as base year. So commodities, they have given you 2010 prices and 2015 prices. So P1 is 2015 and P0 is 2010. So same like previous problem, how we have done, we made the totals of P0, then total of P1, then P1 by P0 into 100. We got all these P values. Then we made a total. Then simple applying the formula, simple aggregative and average of relative method. So how we'll do the simple aggregative method means P01 equals to sigma P1 by sigma P0 into 100. What is P1 here? 360 by 300 into 100. We got 120. See. Then same average of relative method is P01 equals to sigma into P1 by P0 into 100 by N. N is 5. So see the commodities 1, 2, 3, 4, 5. So N is 5. So 611.5859 by 5. So we are getting 122.3. So this is one problem. And next problem is, yeah. So this is next problem. Find out index numbers by using mean, median, and geometric mean. So we have seen how to calculate mean, median, and geometric mean. So see here, they have given you group A, groups group A, B, and C. Years also they have given you 2012, 13, 14, and 15. So what we need to do? First, we need to consider base year as 2012. So see, they have given the 8, 32, 16, like that. So prices are given, relative values are not given. So how we will find out relative values means 2012 is base year. So for 13, how we'll calculate is P1 by P0 into 100. So 12 by 8 into 100, 150. Then 40 by 32 into 100, 125. 20 by 16 into 100, 125. Now make the totals of relatives 2012 and 2013. Now 2014. 16 by 12 into 100, 200. 48 by 40 into 100, 150. 32 by 20 into 100, 200. Now make the total. Similarly, 2015. 20 by 16 into 100, 20 by 16 into 100 to 50, then 60 by 48 into 100, 187.5, 40 by 32 into 100 to 50. Now make the total. Now find out what are the averages. So for 2012, it's a base year, so it is considered as 100. How 100 means 300 by 300, then 400 by 3, 133.3, 550 by 3, 188.3, 687.5 divided by 3, 229.2. Now finding out medians. Medians is middle term. For 2012, the middle term is 100. Then in 2013, middle term is 125. Then similarly, so most repeated number in median is considered. So 125, 200 and 250. So next we need to find out geometric mean for 2013, 14 and 15. So we need to find out geometric mean. So same geometric mean also we got. So next problem C. Eighth one. From the following data, calculate index numbers by using arithmetic mean, geometric mean, using simple average of relative method. 2012 as base year. So in next class we will see to complete this topic index numbers. So next class will continue index numbers, and we'll start with the probability if it is possible. Thank you everyone.